Okay, now I'm recording. Okay, so the tutorial URL is here for most of where this code is from, though it's also a hybrid of some code that is from previous code bases. Look up Indigo Code and you can probably find this tutorial. I'll go through a little bit of it, but maybe I'll just go over the basic concepts since there is a lot of stuff here, and I apologize that I didn't write it while recording, but the fact of the matter was it's been a long time since I've written any of this kind of code, and I didn't know what the hell I was doing, and still only kind of know what the hell I'm doing, so it just would have been a complete waste of time to record it because I just did not make progress quickly enough for it to be worth recording. But I'll tell you some of the basic goals here. So in the previous tutorial, we had like this canvas adapter that wrapped a canvas context where we used it to set pixels. What we want to do now is we want to create some OpenGL code, or sorry, WebGL code, that's going to render pixels to the screen from that off-screen buffer. And basically we want to recreate the functionality of the old canvas adapter from the previous tutorial, but we want to do it in WebGL instead of HTML5 bitmap canvas. And then once we've written that canvas adapter to our liking, we're going to swap out the WebGL canvas adapter with the old pixel-based bitmap canvas adapter, right? So basically we're just trying to write some code that is we're trying to write some WebGL code that is tailored specifically to be refactored into the previous code we were writing, right? So as we're writing it, we got to keep in mind, you know, how are we going to cut and paste this into the main code base and wire it up? And it's not going to be as simple as creating a canvas adapter class that uses WebGL and then just swapping out the components. But it's not going to be as hard as completely not anticipate having to do this and then having to do it, right? So we did make concessions in previous code in anticipation of having to do this eventually. So it won't be too painful when we have to like rework a few things to get this code in here. But for my workflow right now, we really want to concentrate on one problem at a time. So it's best to do this in 2 steps where we kind of work on this code in isolation, get it to a point where it's like ready to use, and then we'll start kind of trying to intermingle this code. So what are some important things I want to go over here? I mean, because there's a lot in this shader, and I'm sorry that I'm not going to go over all of it. I think the most important thing here is we're going to have 2 blocks of memory, or 2 bitmaps. We're going to have one called isomem, and then another one called mammem. And this stands for master memory, but it's because it doesn't really look like it does, because why are there 2 M's? And well, it had to do with the way it used to be abbreviated, because I used to have it abbreviated like this, like master and then memory, right? And then eventually I split apart that variable, and when it went through what do you call it, mitosis? Anyways, when it went through cell division, the M kind of like split into it like that, and now that it looks like that. So if you're wondering why this is such a oddball variable, I'm just going to call this main memory or master memory, and then I'm going to call this one isolated memory or isomem. And this will be a 512 by 512 bitmap like in the previous code. And it's just going to be kind of a thing to get us started. And then we're going to have this one in anticipation of having multiple level maps loaded into memory at the same time. So it's a 1024 block of memory, like 1024 by 1024, and this is 512 by 512. So we're going to have 16 level maps are going to be able to be packed into this data here. Yeah, and this is one of those things that we're kind of like thinking about it now and putting in code to consider it because we know we want it eventually, but we're not going to fully support this just yet as we are working. We're going to work on getting this adapter ready to be put into the code we wrote previously, right? And that's the goal, just to get this code ready so that we can modify the old code to use WebGL. And then, so this part won't work fully, but it'll be like the groundwork will be considered, for getting that part to work eventually. An analogy I used earlier, but I wasn't recording, was it's like if you got a house and the backyard has absolutely nothing in it, and you think you might want a pool in the backyard, so you build the shed off to the corner rather than in the middle of the yard because you think you might want a pool. So because you had in the back of the mind the things you wanted to do in the future, you made this consideration of, okay, we'll put the shed over here. It wasn't much extra work for you, but you saved yourself a lot of work in the future, because if you put that shed in the middle of the yard and then you had to like break down the shed or move the shed because you wanted the pool in the middle of the yard, right? Then it would be a problem. So it's like you don't want to expend a lot of energy coding things that you might need, right? Because all those things you might need, you'll never get to them, right? So the thing that I was like, I might need was, I think I might need to eventually change this code to use OpenGL. So I kept those things on the back of my mind and kind of worked the code in ways that I would think were most conducive to helping me refactor it later to use WebGL. So the idea is to kind of have a when you know the kind of way you want to go with a project in the future, you can just code in a way where you're not going to expend extra energy, but you're going to be, I guess, elegant or careful about the way you do certain things so that you can eventually do the things that you might want to do. I don't know. That's a bad explanation. But it is art to balance not expending extra energy for things that you might want, but also anticipating the things you might want and slightly, subtly changing the way you do things to accommodate those things you might need in the future. Alright, so with that said, what else do I have to do here? So this has mem variable right here, it's an unsigned integer, and that's just going to let us know when these textures have been loaded into the GPU. And the reason for that is the shader logic is eventually going to like sample over this, and if these textures don't exist when the shader code is active and trying to if the shader code is trying to sample from these and they don't exist, then bad things are going to happen. So the idea is that if the shader is running, we need some type of safeguard, and this is our safeguard, and that's going to make it so that the shader will now be able to run before everything the shader needs has been set up, if that makes sense. So it's like an initialization order kind of problem. Um, Now, there's probably a way to not need to do this. Like, you could probably just make sure that, like, before you do, like, GL draw arrays, everything has been set up, I think. But I found this technique to help me in the before, so that's the way I'm going to do it. What else? Okay, so another interesting thing I thought was, so when I create the canvas, I'm going to create it. So here I'm creating a new canvas element, and then I'm going to try to get the body using document.body, and then if the body doesn't exist, I'm going to create a body element, and then I'm going to assign it to the document.body attribute, or is it a property? And then eventually I'm going to, append that to the body. So this looks pretty complicated for just, appending the canvas to the body. But the reason for that is because when I wrote this template, I wanted to keep it as minimal as possible. So there is no actual body in this. There's just a head, right? There's a head, but there's no body. And that's because I wanted to keep this as lean as possible. I could probably get it leaner, but I wanted to keep it as lean as possible. And so I decided to omit the body tag, and then code I had written previously just started to break because my old way of appending a canvas to the body wouldn't work because no body existed. So I changed that a little bit. Like before, right? We're going to set up this OpenGL code kind of similar to how the previous project was set up, so that'll make the refactoring this code into the old project easier, because we're kind of trying to set up the problem the same way that it was set up in the previous code. That'll just make things easier. So we're going to use 640 by 480 as before. We're going to use WebGL2. Don't use normal WebGL. And like I had this, but then as I was refactoring the code, I changed the WebGL version to ES300 because I needed integer textures for what I'm doing. So I just can't use this stuff, so I commented it out. So if you don't have this, then you cannot follow along. So try Chrome, try Firefox, those seem to work for me. But yeah, you need WebGL 2. The shaders aren't going to compile if you don't use WebGL 2. So here, as I was following along with the tutorial, I noticed when they cleared the buffers, they were clearing both the depth buffer and the color buffer with the same color. That didn't quite make sense to me, because the depth buffer probably should be cleared with something like black, to have like no information. And then alpha I don't know about, so I just kept it as 255. We're not really gonna mess with the depth buffer anyways. I honestly was getting just too fancy here. I think it was just, to help me kind of learn. Sometimes I'll like abstract things more than they need to be abstracted. And then I gave it a name where, I could easily identify, where else it was being used in the code and know what it was for. So it's literally called GL Clear Color, so that I know that it's used with the GL Clear Color command, which is kind of obtuse or weird programming, so I'm not sure how I feel about doing it this way. But then, or actually this was the more obtuse part, because it says color buffer bit, but it's not a bit, right? Because a bit would imply a flag, right? And these are not flags; these are individual integers. But so the name doesn't quite doesn't quite reflect what it is. But what it does help with is that these values here are used when we are clearing the color buffer, right? So if I wanted to name this more appropriately, then these would be called like glclearcolor.colorbuffer.r, and I would take out the whole bit part. But then when I double clicked these, this wouldn't highlight, right? Same thing with these down here. It would be more appropriately named if I called it glclearcolor.depthbuffer.r and removed this bit part. But then once again, when I click these, I wouldn't be able to see this right away, and I want to immediately be able to see the logical connections between variable names. So sometimes I will break rules of English, or break other like naming rules if it helps my goal of being able to easily see connections. And so I like to be able to visually see connections. I'm very I don't know, I did much better in geometry than I did in calculus, let's say, right? So I'm just very visual, so that's the way I like to do it. Let's see, we got 3 more minutes. Okay, so this is the vertex program, this is the fragment program, so we're abbreviating ver, so VER, first letters of vertex, right? Fragment, first 3 letters of first 3 letters of fragment, right? So the first 3 letters is how we're trying to abbreviate, and then some other ways that I have abbreviated these in the past. I used to like try to make sure that all the abbreviations always had like a vowel in the center, right? So verpog, fagpog, right? And then here's another way, like this would be like more of a C kind of way, VTX and FRG, because C code kind of does that remove the vowel kind of pattern. But I decided for consistency and not having to remember things, I'm trying to keep abbreviations more where it's just the first 3 letters of the name of whatever word it's abbreviating, just because that pattern seems pretty consistent, and it doesn't take as much mental effort to like pick and choose which letters of the word I'm going to use, right? I don't have to like think as much. And there will be exceptions where I do the old style where I have the like vowels in the middle. But I'm going to try to stick to this style, and then, if I've used old style before in the naming, I'll make like little notes of like what these variables used to be named in old code. So that way, if I ever search for these old code variable names, right, I'll be able to find where they're used in new code where I've, used a different variable name, which I guess technically this comment here is kind of like a technical debt, because like how long can you keep on renaming variables and then keeping a historical archive of what they all used to be called. So shader pack, so this is a little bit more complicated than it needs to be, and once again this was just to help me kind of like conceptualize and understand what's going on here. Right, so this is kind of the information for the vertex shader and the information for the fragment shader. So the shader type, the shader source code, and the shader program. The program is compiled from the shader source. And then same thing, shader type, shader source, and shader program. So this type is a vertex shader. Here's the vertex source. Here's the vertex program. Fragment shader, fragment source, and fragment program. By having these 2 columns of names here, this column and this column, I have more ways to think about the data, and that's going to help me internalize what's going on a little bit better. So that's kind of why that's the way it is, right? And then we kind of loop through here. So I've seen other people, instead of using a loop, like if you were to do this in a more object-oriented way instead of a procedural way, you would probably put this in a function, right? This loop in a function, and then you would put this loop would be in a function, right? And then you would give this object to the function, and then you would call the function again with this object. Oh, sorry. So you would remove the loop, right? And you would put all of this code in a function right here. You'd put all that code into function, and then you'd call the function once with this and once with this. Now the reason why I'm choosing to go with the procedural way is because I want to keep the code as linear as possible. So I'm not going to be afraid of making really gigantic, large functions, because it gets really hard to conceptualize the flow and the order of code when you start chopping everything up into smaller bits. So smaller bits are not necessarily easier to manage. And so I'm not going to chop something into a smaller bit unless I absolutely need to reuse that code, right? Like it's some type of super complicated rendering algorithm and I need to use it in 2 places. Okay, now we're going to put that in a function somewhere and reuse it. But otherwise, I'm not going to try to take any simple functionality and reuse it for the sake of making reusable code, and I'm not going to take complex functionality that I only use once and try to put that into a function. Because all that's going to do is delinearize my code and increase the surface area of my code. And those are 2 things. So it's not going to add any extra value. It's just going to make it more confusing as to what is happening because it's no longer presented in a linear order. And then it also increases the surface area, right? Because when you break stuff off into separate functions, now you got to figure out what that function is supposed to be named. And now you got to give that function named parameters and stuff, right? So there's all this extra stuff, right? It's going to have some extra stuff that doesn't add any extra value. It's just increasing the surface area. I'm not completely anti-OOP, but I do use a hybrid approach of kind of like procedural and object-oriented. So my code probably is weird. What else here is interesting? So all pro is for all program, because I'm thinking of it as, okay, we just take the vertex program and the fragment program and we put them all into all program. So that seemed like a good abbreviation to help me conceptualize this, right? Because then you see the pro at the end of all of these, so they're the same like family of variables in a way. Usually I do like general to specific, so maybe it should have been pro and then prover, profrag, and pro all instead of the way I've written it. But sometimes the whole general to specific thing can be subjective depending on the context of where you're using it. And then also it's sometimes general to specific is not as English sounding, so I'm a little bit flexible with how I'm doing that. I'm not completely rigid of always general to specific. But the important thing is, now that I have decided to call these variables this, that spelling it in the other order is wrong, right? So I'm going to pick one variable name and I'm going to stick to it throughout the whole code base. So you're never going to see pro underscore all, and you're never going to see pro underscore ver or pro underscore fra, or because then that would just have 2 variables with the exact same meaning. And now when you need to search for all references, you gotta like search for 2 different tokens instead of just 1. So I'm trying to, be very minimalistic. What else is important to note here? What else is interesting? So here is some of the code for setting up the triangles on screen. Oh, and I lied about it being 2 triangles. I used a triangle fan, which won't really be evident unless you tweak some of these values here to change the colors. But I find I'm a real sucker for symmetry, so having, oh god, I gotta start a new video. Hold on.